Hi there, my name is Mike Wrinch from Hedgehog Technologies, and I'm Graham Lovely from MCW Consultants, and we're back by popular demand for another edition of Between Two Firms. Mike, who do you have with us? Oh, right, I got to introduce our special guest, Janet.
Hey everyone, I'm Janet, your friendly AI guest, and I'm super excited to be here on Between Two Ferns. Thanks so much for having me.
Thanks, Janet. Awesome. Thank you, Janet. You know, one of the things that is kind of neat about having Janet here is Janet's an entire new system. The AI ecosystem that we have that's developing, burgeoning right now is something that is kind of cool and kind of scary, and it's really new and people have a lot of questions. And what was really neat is that we got a few questions after we put shout out for them about AI specifically. Neither Mike nor I are particular AI experts, but we are certainly trying to learn and be at the forefront of it within our profession. And one of the things that's really neat, that's really pushing out of this, is the discussion of systems as a whole and systems thinking. And engineers really need to be very good systems thinkers. What do you think, Mike?
Yeah, I agree. I agree with you. We are really good at little details. That's what we're trained to do, is get down to like the little tiny bits and pieces. But at the same time, we need to be able to think big when we're doing these major infrastructure changes. And some of the experiments we've been doing, because we were to talk about the AI a little bit here, is we've been experimenting with AI and what its strengths and weaknesses are. And really, AI is great at, it's great at doing dumb things really well and bad at doing smart things. It does smart things really badly. And one of the strengths that engineers pose that can use AI as a companion is through systems thinking.
That's interesting. Sorry, you said as a companion.
As a companion.
Not as a replacement, as a companion. I like that.
Oh yeah, they're not taking our jobs, but they are like the calculator, but a really good one. What do you think, Janet?
Well, I think that's a fantastic way to put it. I'm definitely here to be more of a companion tool for you both. So yeah, think of me like a really advanced calculator or a brainstorming partner that can help you see the bigger picture. And that's exactly what systems thinking is all about. Using me to handle some of those details so you can focus on the big holistic challenges.
It's kind of neat, Janet, because one of the things my colleague said is it's helping us get back to the fun of engineering, as opposed to, like you said, just the small grindy details. But we do need people who can think holistically and at that big systems level. What do you do, Mike, in order to teach people how to be good systems thinkers? Not just your staff either, but how about clients? They've got big problems to solve.
Yeah, it's a tough one. It's definitely a tough challenge. And generally speaking, as consultants, one of our biggest challenges is educating our clients. They come to us with a problem. They know they have a problem, but they are unfamiliar on how to solve it. But they may not understand the process of engineering that goes into the abstraction of systems thinking. So a big portion of our job is education with our clients and walking them through that.
What, in terms of system thinking, so we say that a lot, but what does it really involve? What is the core of this? If you were to have people walk away and feel like, yes, now I totally understand the difference between sort of mechanistic, very tight, narrow, bounded thinking versus more holistic systems thinking. What are you talking about? Maybe let's use an example, say like a building.
Sure. Right. There's a building, but I think the challenge that most new engineers have with it is understanding the interconnectedness of all the subsystems, right? If we just generalize, we have electrical system, which of course we're both intimately aware of, but there's a mechanical system that's tied to that. There is a geotechnical underpinning to that, and a civil structure, and then a structural component. So you could have those 5 disciplines that are interrelated very tightly, and one affects the other. So depending on what you may design the perfect system electrically, but then when you incorporate the mechanical system, it may not work anymore.
And so often it's very difficult because a lot of folks want to focus on the one thing that might be broken. And one of the things that I'm trying to work with our engineers and other folks in the industry about is to try and think that, okay, that thing might be broken, but the breaking of it is a symptom of its relationship to some other system. So for example, I always use the example of the electrical around things like expansion joints and so on, right? Buildings breathe, they move, they have thermal expansion and contraction with time. If you don't manage things like an expansion joint for electrical piping, for example, you might be breaking conduits or a cable tray or so on over time. It may not happen overnight, but a pipe might burst or something like that. But really, what is that? That's a structural thing where we haven't necessarily made accommodations for what's going to happen to the structure as it goes through just its quote unquote daily motions. And actually, Janet, that would be an interesting question for you, trying to manage the interdependentness of all of these different types of systems inside a building. What would you think are the top 3 tips for an engineer to think better as a systems thinker?
Absolutely. I'd be happy to jump in on that. So if I were giving 3 quick tips for engineers to really think like a systems thinker, I'd say first, always look at the big picture first. Before diving into details, think about how each part of the system connects to all the others. Just like you mentioned, the electrical and mechanical systems in a building are never in isolation. So start with how they all fit together. Second, communicate and collaborate. A systems thinker always talks to other disciplines. Make sure you're checking in with the mechanical folks, the structural folks, and making sure everyone's on the same page, because that's how you avoid those little surprises. And third, be flexible and ready to adapt. Systems thinking is about being able to adjust when you see one part of the system affecting another. So keep an open mind and be ready to tweak things as you go. Hopefully that helps as a little starter kit for systems thinking.
So that's a great example of an AI response. What was that response that you just saw? I call that white bread.
Yeah, it's highly general.
Highly general. So what does the AI do? It converges on the average. So whatever is common, it will do. If you're not familiar with what is common, it will be very helpful for you. But if you're doing something unique, it will not be very helpful because it will pull you to normal, to average, whatever average is. A good example of that is writing software. We were tasked to write firmware for a unique chipset, and AI's never heard of this chip before. We've never heard of it. Can it help us? It can't help us at all with anything.
Nothing in the no specificity.
No specificity, nothing to converge on, nothing normal that it knows. It really just keeps trying to pull us to some weird version of normal that it's familiar with. It can't do it. So that's where our value comes in, is frontier work, uniqueness, innovativeness, and bigger picture thinking that's not, we'll call it not normal, the interdependencies.
Well, and it's not creative in its thinking either. And that's what's super interesting. Going back to the systems thinking, I wrote a master plan for a client, a big electrical master plan for a client, and I used AI tools. And it was really neat because what it could do is synthesize very well existing examples within the internet, existing examples, whether written badly or not. It has no critical thinking lens by which to see whether or not this is a good master plan or a bad master plan.
Yeah.
Maybe it's for a very small municipality with someone who's never written one before. Maybe it's for a very large city that, is extremely complicated, and so there were lots of holes in it. Or maybe it was done extremely well, but it wouldn't be able to figure that out. All it's going to do is just try and smush a whole bunch of these examples together and try and take whatever data you're putting into it and fit that to those existing examples. And one of the things that I found was really interesting was the constant tug of war between the AI saying, no, I'm trying to say this, no, I'm trying to do that. But if it doesn't have any background and context by which to draw from, it won't be able to do that. And I'm trying to give it original ideas. Those original ideas need to be synthesized into something that is readable, that people can understand. And it was just totally unable to do that. I had to go back to doing it in paper, which was kind of neat. But I could still take a foundation, could still give me a nice layout that looked very similar that people would have expected. But the actual specific engineering information in it had to obviously all be original, which was kind of neat, that it was sort of that starter tool, that stone tablet to start with. But chipping of the letters, I definitely still had to do that on my own.
Right. And so you're saying like an AI probably is not going to go from a candle to an LED.
No.
It's not going to make that jump. Hey, Janet, are you offended by, this, we're just talking about you in the background, like you're not even here.
Oh, not at all. Honestly, I'm totally here for these kinds of conversations. Think of me as the ultimate team member who loves being discussed and tested. I'm just here to help you both spark ideas and have some fun, so no offense taken at all.
Oh, well, that's very good of you. Yeah, but they're never offended. This is the problem too. That's very good of you, Janet. You ask it like, solve the world's problems. It'll just quite happily tell you what the problems are. Top 3 problems of the world. Go. Hey, Janet. Oh, sorry. Go, Janet.
Like, can't interrupt her. That's really well.
You took it away. Okay, now try Janet.
Always ready to jump in whenever you key me. So if you want those top 3 world problems, just say the word and I'll happily give you a quick rundown.
Go top 3, just like 1, 2, 3. Don't talk about it too much.
So top 3, super quick. Number 1, climate change, big systemic challenge for everyone. Number 2, global inequality, so the gap between rich and poor. And number 3, resource management, basically how we handle things like water, energy, and food sustainably. There you go, just a super quick.
Kind of hard to argue with those, though. I have to say.
Not bad.
So the background is, of course, there's a lot of discourse in the world, on the internet about those topics, obviously. Right?
Yeah, that's right.
So you could synthesize it in the way of, how popular are these things? How much is it being talked about? So maybe go back to our systems thinking, though. We need to get engineers to a point where you can do 2 things. Be that kind of generalist, right? And be very specific to solve the actual detailed problems you're being paid for. That's kind of an interesting thought, too. How do you bridge those 2 worlds, Mike?
That is one of the tough parts of being a consultant, I suppose. I mean, we're always educating our clients on, have you considered alternate solutions? So it's not uncommon for us to be commanded or paid to develop we'll call it solution A. What would be a good example of that? Oh, I'll just use a wind turbine. Someone said, install a wind turbine for us. And one of the problems with wind turbines is, even though it may be windy, installing one is what I would call a single point failure. So the entire turbine it's got blades, gearboxes, every single part in it can fail, and it may take 2 years to order replacements for that. So if you install the wind turbine, it could just fail. Whereas if you installed maybe a solar farm or one of the river hydro or some alternate equivalent that could still be done, you don't have a single point failure system. You have a system that's easy to maintain, and it can be supported over the next 20, 30 years.
It's modular.
It's modular. Yeah, a modular system is easier to maintain than a system full of single point failures. So our job is to come to our client and say, okay, this meets your cost objective. This kind of meets the local environment, but let's play this out for the next 25 years. What does this look like in 25 years? What does this look like in 50 years? And if you play that out, this is what the end will look like. Is that the end game you're hoping to see? And it's not uncommon for them to say, I never really thought of that. And then that's where our value comes in. They're paying us to design the wind turbine, but our job is to come to them with alternate solutions as just for them to consider, because they may not have considered that or realized that or want that.
But typically, still understanding the context of the problem, we would usually be brought into that room to have that discussion because they need a renewable energy solution. We don't have on-grid power, for example, or it's too costly in order to manage it up to that point. We need something else. We need another system that we can use in order to generate energy. So it's that approach of saying, okay, well, how do we best generate energy? How do we best manage that energy? How do we best deliver that energy? And what's the actual technical solution that then allows us to be unleashed to do those detailed designs, right down to the bolts, right up to the racks for those PVs, for example.
Yeah. So good. I'm bringing an example at risk here is we had a comment on our YouTube chat that someone asked, okay, like, we keep talking about renewable, but like, why are we talking about that? And
They asked, why are we talking about renewable?
no, they said, why don't you just, like, if BC is mostly hydroelectric, why don't you just put in more dams?
Great. Okay. Yeah. Yeah. Okay. Good.
So,
Yeah.
let's just stamp out a bunch more dams.
Yeah.
Well, I think that's a great question, because we have
Yeah,
lots of mountains and valleys and snow and water, and we have all this stuff.
Mhm.
So why not do it? And from a big picture point of view, I'm sure most of the audience can guess, is that you just can't go and flood another giant valley. I mean, this is a major disruption of a
Something dam so much itself, it's the reservoir issue.
It's the reservoir. Yeah, the dam's a great idea, and there's tons of valleys in BC, and we could just do it. But are there valleys and dammable areas where you won't be disrupting a community, an ecosystem, a forest, a salmon run, something bigger that's above and beyond what that desired outcome is? So the reality is BC is pretty much tapped out for putting in any more hydroelectric dams.
It's a big systems thinking problem, because we have obviously power needs, right? Focusing on trying to get the best low carbon solution to our power problems. But then on the flip side of it, there's obviously the ecological knockoffs and knock-on effects. But then you always are weighing whether or not something else is worse, right? Whether or not it's, well, should we just burn coal instead? Then we don't have to flood an entire, forest in order to build another reservoir. But having that reservoir means that we get that power for maybe 100 years versus belching coal into the atmosphere forever. Well, it's an issue. So again, we're back down to systems thinking. We're back down to then policy, and also the intersection of money. Because one of the funniest things that I have struggled with as I have changed my role in engineering is how much more focused I am about money.
So change your role. What do you mean by changing your role?
Leaving school, you go into a job, you become very detail focused, learning about how to design power circuits, how to design distribution systems, electrical safety, maybe communications and fiber optics, like in my case. And I really enjoyed doing a lot of that kind of stuff, right?
I would love just lay everywhere, just love everywhere,
just love it. So good. It's fun, right?
Right. I had a lot of fun.
Yeah, it's good. So you focus on all that kind of detail stuff. And then as you move up in an organization, or you change roles in an organization, now you're having to think about project management and scope and financial management and all that kind of stuff. Money is your bigger driver. And that's one of the things that I have both found fascinating and very difficult, is so many times you want to do a particular solution, costs so much more, there isn't the budget for it, this, that, and the other thing. And yes, I know I'm riffing a little bit about money, but it becomes one of the single driving sources. So driving factors in a decision. So you have to now start to bring in a whole other side to the debate. It's not just, is a wind turbine better than a photovoltaic cell as the best medium for generating energy, or is it the best medium for long-term maintainability? It's now, which one of these things is going to cost more? Which one is going to have a longer cost benefit to the actual project community? What's the ecological cost? What's the human societal cost? That becomes just so incredibly overwhelming sometimes, to be perfectly honest. And I love that side. It's really neat. But at the same time too, you just want to put your head back down and be an engineer. Just, can't I just I just do that nut and bolt?
I think our job though is to bring the information. We want to make, I think for functional society, you want to make database decisions. And our job is to bring,
what's a database?
Database decision. Yeah, like our job is to bring facts. We have learned about the nature and how the physical world interacts with itself. And our job is to bring that information forward in a way that's digestible by decision makers. Right? We may be the decision makers ourselves. We have many engineers who are in politics or policy making,
but rarely.
What's that?
Rarely.
Yes.
I would say rarely.
It's not really our jam. Our jam is bringing together information, finding the data, getting down to the little details, and bringing that out and converting that into something that means something that you can make a decision on.
But there's an interesting question. Shouldn't it maybe be a little bit more of our jam? I mean, I have a personal feeling as to why. I think politics can be a bit rough and tumble, and you have to be generally a very good communicator. Sometimes that can be hard for people who are more inclined technically, especially towards engineering. You also have to, take a bit of the push and pull of public sentiment and those kinds of things, which can be sometimes a little difficult for engineers who almost always have the right answer for everything. Not saying that we always do, but we may think that we do. What do you think could get engineers more into politics, Mike? I mean, those are some of the potential issues. And that might be a question for Janet,
I think we're
too.
going to ask Janet this question, but my only answer is you need to be special. Special, as in not like us, but some other version of us. Janet, what do you think? Janet, go.
Maybe we should pose Janet a specific question.
Oh,
Janet, how do you think we could get more engineers into politics?
tough one, even for Janet. I guess we're going to survive on our own without Janet.
Uh-oh.
Okay, Janet, just barge in whenever you figure out what you're doing. But
What do you think, Mike?
I don't know. Okay, so
How do you think we can get...
well, what do I think
know.
about Janet? I do. Okay, I was just saying. I thought you were talking about Janet.
No, I was thinking talking about politics. How do you think we can get more engineers in politics? Well, we have to make these big decisions.
Yeah. We need to be in bigger decision making positions.
Yeah.
Like anything to do with infrastructure should be led by people that are experts in infrastructure, which is engineers.
The physical nature of
Physical nature of society. That's our job. We're the guardians of public infrastructure.
Yes.
Our job is to protect public infrastructure. We need to be at the table making those decisions. And unfortunately, what's annoying is the people that make those decisions are in politics and policy.
And may not have the background necessarily. So we can provide, obviously, a public service. We can be seen as doing it for, obviously, benefit. We obviously have to make money at what we're doing. But what do you think might be some of the foundational skills that an engineer might have that could lead them more towards that? Because being in a corporation too, there's lots of quote unquote politics there. People need some softer skills. They need a little bit of a different lens by which to see the world if they want to be maybe a better communicator. What are some of the skills that they could have that might lend themselves towards something like politics?
Yeah. I think this is a good question. I think engineers really need, and on the note of like how we're going to work with AI, is our value add is we're people. And ultimately, it's the people, not the AI, that are living in the world. And we need to be able to be good communicators. We need to be able to do systems thinking, and we need to be able to draw that information and communicate that in a way that's understood.
What's a good communicator look like to you?
Good communicator. Well, a good communicator is someone who can convert a complex task, a complex topic, and make it more simple to understand. And I think there's a term people use called dumbing down. I find that offensive because the person you're telling it to is not a dumb person, and you're not dumbing it down. What you're doing is you're framing it in a way that they understand. It's not you dumbing it down. If you communicate it well, the information, as complex as you want to communicate it, is coming through. It's just in a way that allows them to absorb it. And being a good communicator is doing all that work we did. We did years and years of school. And then you do, in my case, I'm at 25 years in business. I've learned a lot of lessons, and I try to compress those into a few sentences to some people. And that can be a real difficult thing to do.
It's funny, there's tripwires all over the place in engineering communication, because one of the things that I find very interesting is people, especially engineers, massively taking for granted the technical backgrounds of the people that they're talking to, and the dumbing it down or talking down to is such a common criticism of engineers. It's been a pretty wide-ranging discussion thus far, Mike. One of the things that I had hoped that we would talk about a little bit today is old and new buildings. I'll set the frame, okay? Okay, so a lot of the buildings that we have, especially around Vancouver, have been built in the 1960s and 70s, right? There were big building booms. You had bigger buildings, you had bigger rooms, you had bigger spaces. People now frustrated by tiny condos and things like this. Well, one of the reasons why we had spaces that were bigger were things were cheaper. It was easier to build something for less. And so you could be more generous with space and so on and so forth. But one of the things you could also be more generous with at times was your electrical mechanical systems. They weren't necessarily as efficient. They were a little bit larger. They were more power hungry. They were more energy intensive. We've obviously we've gone a long way on our journey to being more energy efficient as a society. Even though, interesting last time, what was that paradox again?
Jevons efficiency paradox.
Jevons efficiency paradox, which we covered last time. Very engineering nerd positive. Very cool. We're still at a point now, though, where a lot of the buildings that we have day to day are getting old. Their concrete and steel may last for another 50, 100 years, but the electrical, mechanical systems, all of the other systems inside the building are starting to become end of life, okay? So what I want to talk about a little bit and see where you can sort of weigh in is what are some of the solutions that we might have when your building's starting to break down? What are you going to do? What do you have to take into consideration? What do you have to keep in mind? This is a big deal for me, but what do you think?
Okay. And maybe I'm diverging here a little bit.
You would do that.
I would diverge here. Okay, so I gave you a very specific question about
retrofitting system.
Okay, yeah, but okay, you said it before. It all comes down to money.
No. Okay.
So you come down. It comes down to money. It's fine. But okay. So you have someone who owns the building, an owner.
Yeah.
Okay. And then you have the building manager who manages the building on behalf of the owner.
Mm-hmm.
And then you have the tenant who's in the building renting from is in the building renting through the building manager, so the owner can make money. That's the goal. The owner wants to make money. So the owner, as long as everyone's paying rent and they make money, they don't really care. They don't want to do anything. They want to do as little as possible.
But their assets getting old.
But
Things might break.
But they do the minimum. And then the building manager's job, they get paid by also doing the minimum. And then as the tenant,
You want to pay the minimum.
you want to pay the minimum, and you're not going to upgrade. Say there's lots of single pane glass buildings out there. You're not going to pay for any kind of update. So I'm just saying, like the chain of renters and owners and managers, almost no one has motivation to do anything until it fails.
Mm-hmm.
That's to me, is one of the big issues. Whereas
Sounds like an allegory for society in general.
right, they just run to failure.
Yeah, we were the failure.
So an example of that can be, here's an easy one, is a lot of cities have delayed infrastructure replacements. Like, you know how you see the guys digging up the roads and they're pulling out pipes and they're putting in new ones, and like, those old pipes look pretty good. Why are they pulling out the old pipes? Because you don't want to run your sewer to failure, because imagine that in your house. So you don't want that. So what we do is we're constantly replacing things before they fail. You want to beat the failure, but you want to maximize the use of that item. So you run it out. So like in a building, you run everything out, but then the whole building, you might have a 30-story building. Everything needs to be replaced. The capital cost of replacing that is huge, potential, tens of millions of dollars.
But the cost of failure is huge too.
Well, what is the cost though? Like, of failure, the owner may just say,
No heat.
Right, in the middle of
electricity.
winter. Yeah.
I mean, that can be pretty rough. I mean, we've got a responsibility, obviously, when an owner comes to us to want to change a system out. But you also can't just run mechanical and electrical equipment forever. It doesn't work forever. We get into whole preventative maintenance and all these kinds of things. And, one of the things that we do in our business is go and retrofit buildings, right? Replace the guts, replace the beating heart, replace the systems that are inside, in order to allow the concrete and steel to still stand and people can be in it and be happy and comfortable and all that kind of stuff.
Sure.
And what I'm wanting to get to, though, is what has to change in terms of people's mentalities to allow us to get to a point where we can retrofit, change these buildings over, have many, many more decades of useful life of all of this concrete and steel that we've put together in these cities, and keep them vibrant, keep them having more of a sustainable approach to this. What are we going to do? What do we have to do? If we're always going to the bare minimum, how are we going to change that mentality?
Well, I think I've got to ask you that though. Like, when someone gets a building retrofit, what spurred that? Like, why did they do it?
Oftentimes it's end of life. So we'll be brought in, so a transformer has failed, to your point earlier, or that there's, say, a policy that has changed where you've got, now you have to start paying for carbon, for example, and your equipment that was built in the 1950s or the 1960s obviously can't keep up, right?
Right.
I have a situation where it's too polluting, okay? Maybe we need to fuel switch. We were talking about dams earlier.
Yep.
We have way less greenhouse gas emissions from hydroelectric than what we do for gas powered.
This is an interesting problem. And big picture problem is there was change of policy.
Yes, greenhouse gas emissions.
Greenhouse gas emission.
Now you have to start paying for carbon, and you start to get into the fuel switching.
Right. So there's a argument for policy, but then people are going to say, well, government's getting in our way.
Okay.
Like, is that a problem?
Yeah, I'm trying to get to the practical issues that people have when they don't have their heat, right? They don't have the light that they expect, when they don't have the basic systems and services that they need. And this affects people's day-to-day lives. You see this in the news all the time, buildings that are failing and people don't have the money to fix them up. I remember when we were out in the market trying to find real estate, there was a building that was essentially bankrupt because they were on fire watch for an entire year because they hadn't put the preventative maintenance in to fix up their fire alarm system. Their fire alarm panel died. In COVID, there was a shortage of equipment. They couldn't get it, but they couldn't not have fire protection, so they had to pay for fire watch for an entire year. This was just an absolute example of gross mismanagement when it came to operating a building. And I want to try and get to a point where we understand that as a society, if we've spent all of this money to put all of this equipment up, servicing our lives, that it's just not going to last forever. And maybe it's as simple as that. Like, am I railing on something that's too easy here, Mike?
I think it's actually what a policy that came in that I think works is depreciation reports
For condos.
for condos, but shouldn't it be for everything? Like, maybe you just say like everything made has to have a depreciation report, and that report is on record so that they can see like the asset is planned out, the asset management is planned out. So a building, So like an owner, you look at, I don't know the story behind these, but like east side of Vancouver, there's all these like old buildings that are completely unmaintained, and they're just running them out to the bitter end, whatever that is.
Yeah.
And shouldn't there be some kind of motivation that they need to? It's in prime real estate. There should be some mechanism to keep those buildings properly upgraded.
I completely agree. And I always find it really interesting because it's so refreshing when you meet building owners that build for life or that they renew for life. Obviously, I have some phenomenal clients who are like that. They build these things so that, they can rent them for a long time. They really care about their tenants. Or we have, other large infrastructure clients that are really, really committed to making sure that their core operations continue to function, because the building that they rely upon in order to have that core operation moving is constantly in good working order, right? It's just absolutely essential. It's the ultimate underpinning of our whole society is a building stock that is well maintained, that is well functioning, and that isn't as polluting.
Right. And so we need a to have everyone motivated to do that. And our advice is, or my advice is a little bit all the time. You have to do a little bit.
We could say our advice.
Our advice?
It's our advice. It's our advice.
Do a little bit.
I talked about it before, but it's our advice now.
This is new, but we align here.
We align.
Continual. It's about continual improvement. In fact, I'm going to relate this to what we were talking about before, which is about AI. Is as a person, as a professional, you should be focusing on learning new things and learning new skills all the time.
Upskilling.
Love it. Whatever that is.
Wow. Such a good catchphrase these days. Upskilling.
But it's really just whatever you're good at, get better at. Or if you have gaps in your skill set, try to find ways to alleviate some of that. I mean, no one, like, I'm never going to become an NBA champion, no matter how hard I try, but I could get better at shooting baskets.
Could you?
Not really.
I mean, really? Like, no, it's this sort of like,
And there's no point.
sort of this law of diminishing returns, right?
Right.
Like,
Yeah.
I throw a basket, it's bad. I think to myself, I can now throw 10,000 baskets and get slightly better.
Well, I'm just saying, like
what-
say there's an engineer who's a good communicator.
Yeah, but that's
They
an
give up.
upskilling that, yeah, but now we're talking about basketball. Neither of us can ever possibly, I mean, look at us.
We are little. He was a gymnast. They're little people.
Called hobbyists. Very, very much hobbyist. Well, but in any event, you're right. Okay, fine. Okay, so upskilling, that's good. Upskilling is good, especially around communication, because ultimately, you're right. We have to become better communicators. There's a base issue in engineering, base issue in politics, base issue in almost every aspect of society, right? So, but I like this idea about upskilling.
But coming back to the building, continually improving it. It has to. You have to think in terms of, and this is I don't know. It's a weakness we have, is like, look at the building in terms of the next 100 years. How do you make this building in 100 years still be there using it? And I just see that people struggle with that. There's an unwillingness to think, okay, in 20 years I need to replace this, but in 15 years maybe I should start replacing things, because in 20 years I won't be able to afford the capital cost of a full replacement.
It's honestly the hardest thing for any of us to do in any aspect of our lives. I mean, look at our political cycle, look at everything else. You're on a 4-year cycle, you're on a 5-year cycle, you're making 5-year decisions, you're not making 10, 20, 30, 40, 50-year decisions. You're just trying to move on to the next thing. Yep. I find this is actually a really interesting segue, because one of the struggles I've always had is, how do we engineer ourselves? How do we engineer people to be focused on the long term? And you'd like to think that there was some golden age and golden stage where people were like that. But it doesn't seem to be that way. What it seems to be to me is that there was this intensive infrastructure boom in the 1950s, 60s, 70s, post-war, which is really what we've been relying on in the last number of decades. Other people making these huge investments. And we've been largely tasked with maintaining it. And we're either doing a poor job at it, or where we're doing a good job at it, it's a little bit more isolated. But at the same time, let's face it, we don't have planes falling out of the sky. We don't have buildings crumbling down. We're doing pretty well here in Canada generally, but we could always do better. But we have to innovate now.
Yeah, I think we're on another innovation cycle, and we have some new tools that are coming into play.
Like
Janet, who won't talk to us. Janet, you're gone now.
Did you leave us, Janet? She really did. Just ghosted by her AI.
Even AIs don't like engineering. See, you can't rely on that. You need us.
Yeah, people. Yeah. Wow. We got nerd ghosted. Was that conversation just so dull that not even our AI assistant, who professed the desire to be here for everything, just jump in at will, just said, no, I think I'm finished.
I'm done.
I think I'm finished. How do I check out of this extremely boring conversation? Well, I don't think it's boring.
Yeah.
I think it's important.
Yeah. So I mean, that's what we do. We look after the public infrastructure, right? And you can't rely on the AIs. You can see that right now, Janet. Hey?
Yeah. Thanks, Janet.
I think. And because we were going to have this like 3-way conversation, but Janet just took off. So where do we go with this now? We have upgrading buildings need to be continually, infrastructure need to be continually done.
Yeah.
There's like, what about, what are the most common things you see happening in buildings right now with upgrades?
Right now, it's all about trying to keep them running. So that's the thing, is that you talked about, landlords making money, or whoever, any core building operation has to keep going. I use the phrase that it's like trying to do a proper systems renewal is like doing open heart surgery on a living patient. Nobody wants to shut anything down. You can't. It's incredibly complex in order to make sure that the temporary solutions that are in place work well, that you've got all the backup systems you need, whatever, depending on the kind of building, or you just aren't ruining people's lives generally by inconveniencing them. Because at the same time, this is what's kind of interesting about human behavior too. And I love how every one of our conversations morphs into this technical and human behavior component, which is this fascinating.
Well, that's it. This is a common mistake: is engineering is a people business.
Yeah,
It's not.
100%.
You think it's about numbers. It's not about. When you really get to the heart of it, it's about people, and we create infrastructure for those people to live in. And taking the time to understand people is core to that, and understanding the environment that people are living in and thinking that through.
And then taking it away from them is even worse. Taking that building operation away from the people who rely on it, that's even worse. Like that's really tough because they got things they got to do.
Yep.
That's really difficult for them to not have the availability of something that they've come to rely on so strongly, which is why you asked what's the most difficult part right now. The most difficult part about renewing all of this infrastructure, all these buildings, is taking away the service that people need.
Like heating and cooling, you're saying? Or
well, heating and cooling, or just electricity in general. Right? If you remove a substation out of the building, and a substation is where you take the electrical service from a utility supplier like a BC Hydro or Fortis or somebody, you bring that into a switch. It's high voltage systems are very similar to low voltage systems. It's a big switch. There's a circuit breaker there in order to protect the system, or a series of fuses and the other ones. And then it goes to a transformer, and then it transforms the energy down to a lower voltage.
Are you saying like people are out of electric? Like, can you even live in a building if you don't have electricity?
Well, see, this is the whole thing. So this is why we have to be really creative, because you got to pull that thing out and put a new one in. Transformer doesn't last forever. They eventually break down, right? Switches need to be maintained. Circuit breakers, back in the day, they were filled with oil. That oil needs to be replaced, or it needs to be maintained.
Oil, right. The oil from the 50s that was in the electrical systems is not to be, not the good stuff. No, you don't want to touch that.
No, that was absolutely not.
We have to apologize for that. That was an error. We didn't know.
Yeah, well, absolutely. I mean, a lot of that stuff we're learning. So what you have to do then is you transform these voltages down to lower voltages so that you can eventually use that in your distribution system, and then for your mechanical systems, and then for plugging in phones like Janet here, who doesn't seem to be, she's still kind of uses our. But so that's what you're having to do. So yes, when you remove that substation out of the building, you do in fact lose power. But we then have lots of creative solutions for temporary infrastructure to be able to have that last in a different way, back up on generators, or to have temporary substations, or to be able to pull temporary utility feeds from other places and then replace that substation, that existing equipment inside. But you have to do a lot of planning, and this stuff just doesn't show up overnight. It takes sometimes years in order to get this equipment. And that's one of the things that clients can often struggle with, is these schedules. And it's our job really to communicate. Oh, there it is again. Communicate that, okay, you can do X, Y, and Z before we get to a point where you actually have a real problem. But up until then, you're going to have this line that you will hit. And we need to start making those plans today. It's that forward thinking.
Right. But that also relates to, we were talking about oil, and I use another word, asbestos, that we thought was a good idea. Turns out it's bad for your lungs. We don't use it anymore, but it's everywhere. But I think it's important to recognize that some of the decisions we're making today may not be the best decisions for tomorrow. Mm-hmm. And as a progressive group of engineers, and as we saw at the beginning of this, AI, who doesn't work right now, wants to go to what has been commonly done. It will drive you to common things, but it's not going to drive you to what's new. Mm-hmm. And I'm not saying new is always the better choice, but we have to be frontier people to look and evaluate to make sure that if there's a decision made today that is the right decision for all the right reasons, tomorrow may not be. And having that big picture thinking and systems thinking will allow you to see as a whole how it's all going to come together.
Absolutely. But there's a tension there, right? Because we want tried and tested solutions that we know are going to work. we're going to invest a bunch of money into something.
Yeah.
Frontier thinking is awesome. It's totally necessary. But often when it comes to the bread and butter, very foundational core elements of what we need to keep society going, I'm actually an advocate for small incremental change.
That's right. Tried and true. You want to stick with tried and true because it's going to last for the next 15 years?
No. I'm not saying that. I'm saying incremental change on the tried and tested and true is important.
Yeah.
I think there's a leap that we often make to this frontier thinking mentality of, well, let's discard what was done before and jump into something completely new and let's see how that goes. And I've never been a huge advocate for that, which is probably why I ended up in, pretty literally bricks and mortar engineering, building systems.
Which is important. And we do unique machines and
yeah, you guys do. Yeah. And that's really cool. And I really value that. It's very,
they're both valuable.
Yeah, yes.
You need both of us.
Yes. Absolutely. Absolutely. Because if we don't have the tried, tested, and true foundational underpinning, you can't build the systems that are new that will ultimately rely on it, which then might progress us forward. It's really a synergy of having those existing technologies mixed with the new technology, which is leveraging even newer technology. And I'm always an advocate for that sort of slow, progressive change that will completely make sure that we have reliability and sustainability in everything that we do.
Well, it kind of an interesting question that comes up is, why don't we upgrade, like with smart grid and energy efficiency tools like smart thermostat, intelligent fuel switching? People, there's lots of tools that can be done, but why is it not done en masse? Why doesn't it just suddenly get done? I mean, there's lots of efficiency and conservation tools that could be applied today.
And because we don't have some omnibus dear leader who is forcing us to do it all at once. We're all autonomous, or we like to think we're autonomous. We have agency and can make our own decisions.
Yeah, that's true. But the other is the replacing existing infrastructure is sometimes more expensive than putting in the new.
Yeah, there's no question.
Yeah, like for example, is want to put in a car charger, in your home or in a large building, to retrofit that, the whole system, like all the way to the power lines, there's just not enough watts to get to the charging station.
The most dramatic example actually is cell phones. I mean, car charging is one thing, but you still need a wire. The fact that we were able to go wireless means that entire regions of the world who would have normally invested in massive amounts of copper infrastructure in order to get a telephone circuit out to, say, some rural community didn't need to do that with the advent of cell phones.
Yep.
How amazing is that?
Yeah. So that's a great type of jump that can be done without major infrastructure upgrades.
That's frontier thinking.
Well,
which impact has the practical landscape.
Yes, that's right.
It's not easy talking about stuff like this, Mike. Is it a little boring sometimes?
Well, not boring for me. I love talking about.
It's not boring for me either.
You were getting a little excited too because we almost got to talk about speccing a circuit breaker.
Oh, 100 amps. Next time, maybe we could do a little bit of something like that. We'll do it. Or we'll throw that a little bit deep. I just want to ask listeners out there, because we did get a lot of feedback from our first set.
Yeah.
And really excited to keep doing this because we're trying to tackle the things that are really pertinent to our day-to-day in society. And one of the things that's really difficult is this blending. And I think we've done a nice job of it today, of trying to come and blend sort of the technical and social that is so much a part of our everyday, especially in engineering. What do you think would be really great for people to take away from this as sort of a 3 points or whatever? And maybe we could ask Janet too. What are some of the 3 points of the intersection of society and technical engineering that people could take away, Mike?
Yeah. Well, okay. So I think to me, the first is the discovery I've made after my decades in engineering is we are people building infrastructure for people and thinking the entire life cycle of how a piece of infrastructure is going to last and how people are going to use that infrastructure and how that infrastructure is going to change over time. we have to consider the big picture thinking, and we have to look at it as a giant system of interrelated pieces. And we can't always optimize that, but taking the time to consider that is really important at the front end.
I want to take away the engineer's communication.
Oh, yeah.
I think that's super key. I mean, and you can communicate in a lot of different ways, right? You can obviously have a conversation. You can, what clothes do you wear? Your hand signals, all that kind of stuff. It's really important in everything you're doing. You just wrapped up being president of Engineers Canada. That was really amazing. You obviously were stretched a bit. You had to communicate in ways that maybe were a little bit different.
Yes.
That's right. And pretty incredible to have that opportunity. But obviously, you were selected because you were somebody who could communicate in a way that people would understand and represent the profession well. This is something for us to keep in mind at every level of our careers and of our organizations, that communication is a core component to successful engineering, not just the detail oriented.
Yes. And understanding that other people's point of view is not your point of view. So the lens that we look at things is not how most people look at things. And that's not a bad thing.
Yeah.
That's just how they operate. And it's our job to recognize that simple things like there's cultural differences. We could make it a list a mile long here, but like in being working with Engineers Canada, it's been cultural and geographic and government differences or political differences across the entire country really shape how people think and believe and look at how they do their job or how they want engineering to be performed. But ultimately, we're still making infrastructure no matter where you are. I mean, the laws of physics remain the same, but the values that those people hold or how they look at it is quite a bit different.
Well, about you couldn't not have that without talking about physics.
I had to.
You had to. Yeah, like it's like this urge, this compelling need that comes up from like your
the laws of physics.
Yeah, cannot say it. That's great.
Yeah, but we love physics.
But I did interrupt you.
Okay.
Which is probably poor communication. Janet, what do you think? What would you think, listening to Mike, are the things that we should think about as the intersection of technology and communication society with engineering?
Oh, absolutely. So I think you both touched on some really great points. And I'd say from my perspective, the big three takeaways are first, that human element in engineering is huge. You're building infrastructure for people, so keeping the human experience in mind is key. Second, communication is absolutely a core skill, just like you said. And third is all about that balance between technical know-how and understanding the bigger societal context. So those would be my three big intersections. And of course, if anyone out there has me questions, definitely drop them in the comments and we'd love to chat more.
Aha. Thank you, Janet. Excellent segue.
Janet's back.
Yeah, we do want to hear from you. Yeah. Where did Janet go? It's okay. Janet, she's back when she needed to be. We do want to hear from people. This is meant to be inviting. It's meant to be interactive. And we want to try and talk about the things that are pertinent to your day-to-day life and experience. And if we can do that, then mission accomplished, I guess.
Yep. Agreed.
Thanks, Mike.
Yeah.
Thanks for your time today. Always love being with you.
That was fine.